today's experiment. It is one of my favorites. So to kick us off, I would like us to think of a question. Have you ever watched a spaceship launch? Well, I have. I've seen one on TV. And when a rocket launches, it is all part of a chemical reaction. So, before we launch into our experiment, let's talk about that word react. What does this word reaction mean? And what happens when two things react or have a physical or chemical change? Today, we are only going to talk about chemical change. A chemical change is when you put two substances together in order to make something new. And now, it's important to note, when you make this new substance, you cannot change it back to how it was before. So, let's think. When you are burning a fire and you have a piece of wood, you light that wood on fire and you wait until it turns to its ashes. Are you able to take those ashes and form it back into that original piece of wood? No, that is because a chemical reaction occurred. You made a new substance. So, I'm going to demonstrate this for you today by demonstrating a chemical reaction. So, follow me outside and I will show you. Okay, so now we are going to create an example of a chemical reaction. So here I have baking soda and vinegar. You can see we are outside, so we are a safe distance away from people, places, things like cars. And I also have my safety goggles, so I'm gonna put those on before I conduct this experiment. The two things we are looking for are, we have our two substances that we're mixing together, so we want to be looking for what new substance is created in our chemical reaction. Okay, let's do it. Okay, so I'm going to pour some baking soda into the bowl. Just a little bit is enough. And then I'm going to take my vinegar and I'm going to pour some vinegar onto the baking soda, and I want you to watch what happens. So let's pour a little bit more on. So as you can see, it kind of fizzed up and some of the baking soda dissolved, right? It disappeared almost. So you guys saw that a chemical change took place right before our eyes. A new substance was formed, and like we talked about at the very beginning, we can't bring our baking soda back to its original state, right? So let's take this idea and let's apply it as we now move to complete our steps to launching our rocket. And as we are doing this, I want you to be thinking when, if, and where a chemical change is taking place. I want us to now turn to our rocket and just look at it. What do we notice about it? The shape, the structure, the size? How do you think the fins of the rocket would help us? What do the lines represent on the side of the rocket? These are all important questions we need to figure out in order to help us launch it. Let's begin with the fins. I want to just take 30 seconds and I want you to write in your journal why you think the fins of the rocket are important. Pause the video and play it once you have recorded your responses. Welcome back. So, the fins of the rocket are very important because it keeps it from wobbling in the air. It also keeps the rocket pointing in the right direction. So when we launch it, these fins will keep it going in the correct direction. All right, everyone, now we are going to talk about how to launch our rocket. Before we can even begin, our top priority is safety. That is the most important thing. As you can see, I am wearing my safety goggles. So you all have a pair in your box. I would like you to put them on and keep them on the entire time. You also watched a video from Dr. Disler about all the safety procedures. So if you need to go back and rewatch it so you are familiar, please take a minute and go do so. Once you are comfortable, we are going to go ahead and move on. First thing, we are going to take our rocket and take off the top part. We are going to unscrew it. Now, I want us to take our Alka-Seltzer or our aspirin sodium bicarbonate. Whoa, that was a big word. So let's back it up a minute and say it again. Aspirin sodium bicarbonate. And that's another word for citric acid. And citric acid is found in lemon juice and lime juice. And we are going to take this, and I would like you to break off 1/4 of your whole. Once you have broken off 1/4 of your whole of your Alka-Seltzer, I would like you to put it in the top part, in the cap of your rocket. Next, I would like you to recognize that we still need the other part of our chemical reaction. Remember at the beginning we talked about that there are 2 parts to a chemical reaction. Our citric acid is first, and now we need water. So we are going to pour 20 milliliters of water into our rocket. But wait, back up again. Milliliters, does that sound familiar? Probably not. So here in the United States, we use customary units of measurement. Around other parts of the world, most parts of the world actually, they use the metric system. So while we use ounces and pounds, they use liters or milliliters. So I want you to find your line of 20 on your rocket in your water, and I would like you to fill it up right to the line. So you can see that was a little too much. Perfect. So it is right at 20. Now, it is time to put our 2 substances together to form our chemical reaction. Remember, when you are doing this, do not look directly over the rocket and keep your glasses on at all times. Make sure your parent, your guardian, or an adult is with you. Now, we do not do this inside. Remember, I told you at the very beginning. So, you are going to screw your lid on super, super tight, and then you are going to wait for it to blast off. So, go outside, screw it on, and I am going to wait for your results. Please do not forget to record everything that you see in your journal. And an additional thing that I would love for you to do, see if you can draw what you think the chemical reaction looks like. All right, let's see if your rocket launches higher than mine. Bye. Well, how did it go? Did your rocket go higher than mine? Mine went almost 30 feet. Can you believe it? So now that we've done it once, let's talk about some variations or changes that we could make next time we try to launch it. Could we try a different amount of water in our rocket? What would happen if we adjusted the temperature of the water? What if we put cold water in? What happens if we increase the amount of Alka-Seltzer? What would happen if we put a whole tablet in? Do you think any of these changes would make a difference in the height of the rocket? And why do you think so? Each time you try a variation, record your results in your journal, and please feel free to share. I know I'm going to go try some more, and I can't wait to see if I can get my rocket to launch higher. Remember to stay safe, wear your goggles, and have fun. I'm going to go blast off now. Bye!